We were thinking about, would a reverse beacon network be an asset to both other people and to the club here? So, Bob, we really are glad to have you back, and hopefully you can give us a little guidance here.
Let me start by sharing just a screenshot before I get into the slides. So you should see a live view of the one and only station that I see spotting from the Washington State right now, which is K5EM. I don't know if you guys know him. Apparently, he's located in the Seattle area somewhere, and he's been a long time spotting help. But of course, Seattle has different propagation than the Spokane area. I assume it's the other side of the mountain there, and of course, you're farther east and maybe a little north. So it'd be nice if we had another node there in case his goes down. Uh, Ideally, a reverse beacon network should be located in a quiet area with a good shot in many directions and good antenna, kind of an omnidirectional antenna. But preferably someone who is not on for a contest, because when you get on from a contest from the same location that the reverse beacon node is located, well, the node gets overwhelmed with the transmitter nearby and doesn't do as well. So that's a start there, is to show you where things are now in terms of the reverse beacon network. And the kind of equipment, I'll go into a few details. It's not cheap these days. There are cheaper alternatives, but they don't work as well, or they require a lot more work. So just to give you an idea of the cost involved to get an SDR that can skim 16 bands at once, which is sort of the minimum thing you need. Here's another share of a screenshot of the DX Engineering website that shows the Red Pataya SDR lab 12216. Easy to remember name. He's only got 3 left in stock, and they do cost $739. And that one little box, though, has 2 antenna ports for input, and it can be set up with free software to automatically skim up to 16 bands, 192 kilohertz wide. And of course, you need a PC to connect to that as well. As far as the antenna goes, that it's hard to make a broadband antenna that works well. But let's see if I can get to this one. Here's one that I used for a while. It's the DX Engineering RF Pro 1B loop. It's very easy to put up. You don't have to get it high off the ground, 10, 5, 8 feet. And it actually covers 160 through 10 quite well. And it has a preamp in the base. And that's sort of a complete kit. But that's kind of the prices we're talking about. If you're looking just to get the receiver and a broadband antenna, and you can use a long wire. You don't have to use that pixel loop. Some people use some kind of a long dipole with ladder line, some kind of broadband receiving antenna, or a vertical like HF6V or HF9V or something like that. So that's the kind of equipment, and certainly would be a good idea to have an extra node in your area, because K5EM may not hear everybody, or when the network gets busy, his node may go down. So having a backup from that area would be a good thing. With that, I'll start showing my slides. This was presented at Contest University a while ago. Some of this a little bit dated, but it's mostly covering how to use the reverse beacon network, as not quite as much about how to actually support it, but it does explain how it works and how stuff gets to everybody. What I'll go over with you today, and how does it work and what can it do for me if you're a user of the network, but a little bit about how you can help the reverse beacon network, which kind of covered up the front here already. And what's new is actually kind of what's old, because these slides are sort of old. But how did it come about? Well, there was a very brilliant software engineer. I'm a software engineer myself. I'm overly impressed, incredibly impressed by what Alex E3NEA has managed to do. He emigrated from Ukraine and been in Canada. This is an older picture of him, but programming is hard work, so that's kind of what he looks like a little bit more recently. And that picture there may be 10 years old. But he was honored as the Radio Amateur of the Year in 2014 for his software, not just Skimmer, but Morse Runner, and a RTTY skimmer called Gritty, a RTTY decoder. He is an OmniRig kind of software. That's all one guy, VE3NEA, incredibly productive software engineer. So CW Skimmer, what is it? It's a piece of hardware and it's software defined radio. Here's the two pictures of the popular software defined radios. The Perseus SDR on the right is just kind of single band at a time, and it is a very robust front end, but it's no longer made in this form. The one on the left is the red Pitaya SDR that I mentioned earlier in its case with the fan, and that one has two SMA connectors for inputs. That box can also do other things like turn into an oscilloscope and so on, but the one I recommended there in the links up front was the one for skimming 16 bands. And you need a broadband antenna. This picture on the right here is the pixel loop I used to have in my backyard. I'm now using a VE3DO loop as my skimmer antenna. It was just a 40-foot wire. Something went wrong with my pixel loop. I haven't had a chance to debug it yet. Unfortunately, this nice DX Engineering kind of dipole broadband array is no longer available, but the magnetic loop is still available. So what about the software? Well, there's kind of two versions of the skimmer software. There's the one on the left, which is one band at a time, and it shows, a pattern of the dots and dashes and a very narrow bandwidth. And then there's the other one, which is just called Skimmer Server, and the only real UI for it, other than the setup, is it's just a little icon that lives in the corner of your taskbar when it's running in the background. It doesn't have the fancy display, but it does up to 8 bands per skimmer server, and you can fire up 2 skimmer servers at once. So here's just an overview of the first one, the CW Skimmer. It works with many different SDRs, but not all of them. That's another problem. If you think, oh, any old SDR can do skimming, unfortunately, it's not the case. And it can monitor one entire band at a time. And it has this waterfall display and the band scope. And it does use a master data file to prevent or to help it post good call signs as opposed to busted call signs. And it provides an emulation of a telnet server like a DX cluster, so your local software can connect to a local port on your PC and get spots like it was getting them from the internet, but they're just coming from your PC. A Skimmer server has this UI where you can check which bands you want it to skim. It can do up to 7 bands with the QS1R SDR, which is no longer made, but it can do 8 bands per skimmer server on Red Pitaya, and it can set up 2 instances and then do 16 bands. It natively only supported the one SDR, the QS1R, which is no longer made, but folks have figured out how to allow the Red Pitaya to work with this, and it'll decode multiple signals in real time up to 16 bands. Doesn't have a waterfall or a band scope, and it doesn't use the master file, but it does provide the telnet server. RTTY Skimmer server, which is a real CPU hog, and you need a powerful CPU to decode RTTY on multiple bands. Looks like this. It's a separate license fee. I said software was free, but I think there's like a $75 one-time charge for Skimmer server and something similar for RTTY Skimmer server. You really need a powerful PC to run RTTY Skimmer, but it can do as well all the bands, and it can actually share the same SDR. And so with one SDR, you can do CW and RTTY skimming at the same time. It draws these little yellow dots where it identifies a RTTY signal. And it, again, uses the Red Pitaya. And there are some clones of the Red Pitaya that I'm not as familiar with setting up. They're cheaper. I think it's called PDSDR. But you kind of have to build it as a kit. It's a lot more work to get one of those going, in my opinion, but some guys know how to do it. It does require that high-end CPU, and it just has this limited band scope, 1 per band. But there is no master data file, and it has the telnet server. So here's what the output of the telnet server looks like if you were to connect to it with a terminal program, like telnet or your logging software program. You give it a port number 7300, and localhost essentially means your IP address of your local PC. And as you can see, it displays not only the call signs that it's decoding, but also how loud it is, the signal to noise ratio. and which is a very accurate measurement. That it has a very fancy algorithm for measuring signal strength. It also tells you on CW spots how fast CW is being sent. And those are, it only is going to show you, it shows you the stations that are CQing, and it also on your own local node will show you other stations that decoded that aren't CQing. Those stations aren't usually forwarded to the reverse beacon network because, of course, you only want to spot stations that are CQing, not everybody adheres on the band. So what is it actually doing? It's using any CW or radio signal as a beacon. That's kind of why we call it the reverse beacon, is that instead of you listening to a beacon, your signals transmitting are the actual beacon. And these skimmers, they hear your signal and calculate the signal to noise ratio at that location and the speed. And then there's a program called aggregator, which takes all the data from your skimmer, filters out the non-CQ spots, and it sends them to a central server, reverse beacon network server. And that server then distributes those spots via its web page, the one I showed you before with all the lines on it, and also public telnet servers like VE7CC node gets those spots. And then your software connects to those. So you don't have to have an SDR to take advantage of seeing spots on the reverse beacon network. But how do these spots get to you? Well, it starts with somebody like having an antenna like the pixel loop that I talked about, and then an SDR is there, and that connects to a PC that's running two pieces of software: the skimmer server, which is VE3NEA software, and then the aggregator program, which reads that, takes that output of that software and feeds it over the internet to the reverse beacon network. And then what we call retail DX clusters like the VE7CC node or DX Spider nodes or others are the ones who subscribe to that server and distribute it to the users. And that's how it gets to you. Before I go any further, I really have to give some credit out to the folks who made all of this work in the first place. Felipe PY1NB created the website and did financial support from various donations. He started out with dxwatch.com, which I think is still around. Then there was lots of code written by W3OA, who wrote the aggregator software, and then F5VIH did the online spots analysis tool. And then Pete N4ZR, who actually has a little blog about the RBN, and we call him the chief evangelist. And then there's a telnet servers that are supported by a lot of guys, including K5TR and my friend KM3T. Here's a picture of Felipe. He was the one who created and maintained the website initially. And then here's Dick, W3OA. I think a photo I took at Dayton many years ago, who created the aggregator. I've never met F5VIH, but I found this picture on the web of him who wrote the spots analysis tool, which I will show you a picture of later. And this is an older photo of Pete N4ZR, who has presented it at Dayton. And he has, he kind of is the moderator of the Skimmer Talk Reflector, which is an old-fashioned link, but then the more modern one that folks are using is this groups.io link, RBN Ops. And certainly if you're hosting a RBN node, I strongly encourage you subscribing to this, where you can get all kinds of help setting up the node and getting online with it, getting this SDR to go. So what can it do for me, which, the end user of spots? You can fill in spots on your band map. When you call CQ, it spots you every time you call CQ. If you call CQ the right way, you'll get spotted. And this is really helpful. If you just installed a new antenna, want to see if it works at all, or you got RTTY set up and you're not sure if you're keying upside down and you just call CQ. If you call CQ, you're going to get spotted somewhere if you're getting out at all. And of course, if you're in a contest, you might point your beam one way and then get a signal report from a node, and then turn the beam the other way and get a signal report. You get an idea of what the front to back ratio is like. And during the contest, a lot of contest software will actually, as soon as you call CQ, it just lights up the map with lines showing all the skimmers that just spotted you. And after that, you can compare the signal strength with your competition after the contest and see how you were getting out to Europe or Japan or wherever compared to your crosstown rival. I want to make sure that skimmers spot you. You want to make sure you call CQ the right way. And you want to connect to the RBN if you're in assisted category using your favorite cluster, like V7CC node. And when the reverse beacon network is going to post a lot more spots than the human DXers these days. On CW, you'll see very few human spots compared to the skimmers. They're just faster at getting everything going. Smaller pileups, less competition because there's more spots are spread out, as opposed to when a human spots, most of the people are still listening to human spots and ignoring all the skimmer spots. And therefore, the pileups are bigger when a human spots you than when a skimmer spots you. And it fills up your band map quickly, and it helps you also figure out, because your band map is full on the contest software, where the clear spots are, where nobody's been spotted calling CQ. Chances are that's a good place to put your VFO and call CQ. It should be a clear frequency. So another thing it does is it reveals the band openings, and it shows where you are being heard. And for example, I was at K3LR at sunrise waiting for 15 meters to open with all the beams pointed at Europe, and called CQ, and I saw a spot. We were spotted by S50 ARX in Slovenia, probably on some mountaintop. But the first European didn't answer us on CQ to 25 minutes later. They were still on other bands or whatever, waiting for the sunrise, waiting for our sunrise to happen. So it's really good indicator of when the openings are going to happen. So what's the right way to call CQ so that you actually will get spotted by the skimmers in real time? You want to try to send everything at the same speed. There's contest software by default will speed up and slow down the exchange, like send 599 real fast and then the call sign slow. Well, every time you do that, Skimmer has to reset and figure out how long a dot is and kind of won't decode as well. So if you just call it the same speed, it'll decode faster. The things it's looking for, it likes to see your call twice. And so I tend to call CQ as shown there, both with my call sign twice. It recognizes certain symbols as a CQ. If you just sign your call without calling CQ, it won't spot you because it doesn't think you're CQing. And you want to have spacing proper between the words. You don't want to just send everything with the paddles and rush everything together, because then it doesn't distinguish the words and won't decode as well. And if you change your frequency slightly, you can get spotted again. Each skimmer is kind of by default not going to spot you every time it hears you. It's only going to spot you once every 10 minutes, unless you move to a new frequency. Then it'll spot you again. So if you're doing like antenna testing, you might point the beam one way and call CQ, and then move like 1 kilohertz and point the beam the other way and call CQ, and see if the same node spots you again without having to wait 10 minutes for that to expire. So what does Skimmer count as a CQ? Originally, it was just these keywords, CQ, test, and QRZ. But later they added, or B3NEA added FD, which is what people call on field day instead of CQ, and SS for sweepstakes, NA for the North American contest. And then, of course, these expeditions, they don't send CQ, they just send up after they are working a station and working split on CW. So here's some examples. Maybe someday we'll hear P5DX on the air sending up. Everybody a little crazy. And as you can see, I'm sending the call twice to ensure that Skimmer decodes it twice the same way and then spots it. If you have a short call like W1F or something, a special event call, you always want to send it twice to help Skimmer identify it quickly. And again, the POTA guys on CW, you guys will get spotted by the reverse beacon network if you call CQ this way. Even if you just have a weak signal, some skimmer somewhere is going to hear you. So I'm going to kind of skip over this. The idea is if everybody clicks on a spot, all the radios are so accurate these days, everybody ends up 0 beat on each other, and the DX can't hear you. So I would, instead of randomizing the transmit frequency, I would just use your XIT to move a little higher than where the spot told you to go, or a little lower, and you will get through easier. So to check antennas, as I kind of mentioned before, you can call CQ on CW or RTTY, and then QSY a bit, turn the beam and repeat. And you can then use the spot analysis to also later to, which I'll show you a picture of, to compare your signal the competition. And there are all of the spots that have ever been recorded. If you ever have been on and called CQ in the last, I don't know, 10 or 15 years, chances are your call has been recorded in not audio, but the spot itself has been recorded in a raw data file that you could actually find online to this day. And you'll see how you were getting out. I guess it's everything since February of 2009. That's a long, wow, Skimmer Network's been around for 16 years now. So if you're single op assisted or multi-op, then you can use the reverse beacon network. Some contests like WPX allow all entrants to use spotting. Other contests like sweepstakes have separate categories for assisted and not assisted, meaning using spotting or not. There's a long list of cluster nodes at this website. And then some of these clusters have Jose's spot quality filters, which are attempts to flag busted calls and unique, so that because the skimmers, even though they decode pretty well, each individual skimmer can make an error now and then they all add up and look like unique brand new ones to work when they're not. But that's why I like the B7CC node, because it automatically removes a lot of bad spots. Any unique call sign, it waits until another skimmer spots the same call sign on the same frequency, and then it posts a spot for you to see. So connecting to CC cluster software, you will see many fewer bad spots than if you just use the raw networks. I'll just kind of skip this. This was sort of the commands you could send in the old days to DX Spider, for example, if you just wanted to filter the spots and see spots from like the Western zones. Here I've picked the, Alaska, California zone, zone 4, and then Mexico zone 6 and 7 is they're sort of the Western US, and zone 31 Hawaii. And I also said not by W7ZI because W7Z7I is in Pennsylvania. And I didn't want to see his spots. And then that's one way to filter. And then if you connect to an AR cluster node, it's a little different syntax, but you can't say unique greater than 1, so that if it's non-unique, then you see the spot. And you can and filter by the spot or state, for example. But this AR cluster software is no longer maintained. I think the guy who wrote it, is it AB5K, something like that, passed away, and nobody has the source code or current source code, so it's kind of stuck the way it is. But fortunately, we still have E7CC around, and his nodes are very good. And he's got a whole document on how to use his software, and you can set the filters by command line, or you can use this nice graphical user interface, which I'll show you a picture of, which automatically rejects, unique. I mentioned it already. Automatically rejects the unique spots and eliminates all the dupes. And he's got a tutorial on this site about how to use the RBN. So here's kind of a picture of what the CC user filter dialogues look like. You don't have to keep this up all the time. You just run the software once, send your filters to the node with your call sign, and then it filters. And in this case, the green means pass spots from these states, DX origination or Canada or anywhere in K, for example. So you can filter them that way. So it also combines human spots with spots coming in from skimmers. But on CW and RTTY, there's far more spots by robots than by humans these days. A phone's a completely different story. The other nodes that you might consider, AR cluster node W9PA can work, and it's got the skimmer quality tags. And there's some other telnet servers around. So one useful thing you can do is you can go to dxmaps.com. I think this link still works. And if you click on the LFHF button, you can see where the spots are being heard. So here's the LFHF button that kind of filters things for HF bands where most of the skimmers are running. And you get an idea of where propagation is currently going, and you can filter by band. He's kind of color-coded the bands here, and you get this nice map. Similar to what you might see on PSK Reporter for FT8, but this is just CW and RTTY spots, if that's what you're looking for. And you can select all bands, and in their options, you can pick some other things. This, I think, was a comparison of human spots versus the non-human spots. So it's quite a bit different. I think let me go back one. I think this was all the human spots maybe, and this was the skimmer spots at the same time. So you can see the skimmers were performing quite a bit. There's a good talk about propagation and how Jose uses the FT8 spots to analyze propagation. You can watch it on YouTube here. There is a copy of this presentation on my QRZ page. And then FT8 spots, as I mentioned, are shown by PSK Reporter. So what about using it? It's going to be your own CQs. They'll get plotted on a map. And then I'll go over the spot analysis tool that sees how you're getting out. Raw data files and also downloaded, and millions of spots are archived. So if you go to reversebeacon.net, just click on the main button over there, and you'll get a list of all the spots from everywhere. But you can search by call sign. And in this case, I put in my own call and clicked search. And so it showed every node that was spotting me on that particular day. And you can go back and pick any time period. We could do a little live demo here. But if you want to plot them on a map, well, the reverse beacon net plots them. You can enter your call, and as I showed, and then it'll plot, for example, here's all the skimmers that are currently hearing AH6AA calling CQ. And so in this case, the spotted station is the same AH6AA, and my node copied it as well as all these other ones. And this happened to be on 20 meters. So you can see how useful that would be to figure out how you're getting out. And it'd be nice if that was in your area of Washington too, for those folks to see if they're getting into that spot. So let's talk about the spots analysis tool. Back to the main reverse beacon network page, you click on DX spots and then spots analysis tool. And this is great to do after a contest. This data is updated at 0 Zulu every day for the prior 24-hour period. So you pick a date. In this case, I picked the date of the California QSO party from 2011. And I have to pick a node because you want to compare signals from the same node. So I'll look for one that has a very large number of spots in North America. I wanted to see how I was getting out compared to my crosstown rival K6XX in this contest. I had more spots, but he, as you'll see, you can add a call here. I just added those two calls. So this will show all and plot all the spots of my call and his call made by K3MM on that date. And it shows all the bands where we were heard. And as you can see by the yellow display here, K6XX signal was a lot louder than me on 10 meters. And I was in there, but I was way down. And on 15 meters, we were about equal, as you can see by the plot below. And what I discovered was that my 80-meter Yagi, which had T-bars on it, sort of capacity hats, they were wiping out the effectiveness of the 10-meter beam that was right above it. And we've since shortened the T-bars, and now that problem went away, and I should be just as loud. You can download the raw data by going to this download raw data link on the website. And then you can pick any date going back to 2009, and it gives you a zip file. It's called comma separated values. Looks like this. It's something you can import into a spreadsheet, but on contest weekend, the file will be too big to import. So I have a free little batch file that strips out only the calls or the nodes you're interested in, so you can plot it easier on a spreadsheet. These are some old statistics about how many spots were happening during major contests. This was during CQ Worldwide CW in those years, and you can get a good idea of activity and conditions that weekend. ARRL DX CW, also lots of spots, way more than you'll get on a typical weekday where everybody's on FT8 instead of CW. It can also do some fun stuff with the statistics and figure out, how fast are people sending on average of all the spots. Anyway, average the speed reported in every spot. As you can see, the average speed is about 30 words a minute pretty consistently, a little faster in CQ Worldwide than ARRL. Those European guys like to go fast. What about RTTY skimmers? There's not as many spots, especially these days, but contest weekends, you'll see plenty of RTTY spots. I do have my node skimming for RTTY on the main contest bands, 160 through 80 through 10. But there's so little RTTY activity during the day, during the week, and non-contest weekends. Everybody moved on to FT8. So having a RTTY skimmer going really chews up the CPU and maxes it out. And I'm not sure it's really worth it anymore. The fan in my PC runs at max speed all the time because of my skimmer running RTTY all the time. But it's useful for folks who are just testing before the contest to get on call CQ and see if their RTTY is keying right and they're being decoded and they're not keying upside down. So I like to keep RTTY nodes going. If you have the CPU that can handle it, like a Pentium, an Intel i9 or an i7, that's usually fast enough. An i5 probably not fast enough to do RTTY skimming. So how can you guys help? Well, please do set up an SDR because they're not always online. And skimmer spots that are fed to the RBN are fed to everyone worldwide. And we do need more in overseas than in the US, but certainly more in the US, especially in your area, would be helpful. If you want to call somebody who's spotted by a skimmer, remember the frequency is going to be very accurate, and you probably want to call off frequency to have a better chance of getting through. Everybody's zero beat is not going to get through. This is not really what's new, but you can actually use the skimmers to spot HF beacons. I do a lot of spotting of 10-meter beacons with my skimmer. You need to cover those segments of the band between, 21,100 and 21,200 or so. 28,100 to 28,200 for the 10-meter beacons. And of course, the NCDXF beacons are on 20 through 10, including the work bands. This is the RTTY board, which was new in 2019. They still have them in stock at DX Engineering, and it is optimized for receiving. They have a cheaper model, the 14-bit one, but it was not optimized for being an HF receiver, and I would not recommend it. It also can't do 16 bands like the more expensive one. Yeah, the old one can only do 8. And then the aggregator, I think they're up to version 6.6 now, and it will actually post FT8 spots to the reverse beacon network as well, but they're not shown online. There's just too much volume. PSK Reporter is already kind of covering that. So here's final links about how to download CW Skimmer and Skimmer Server. You can use them free for 30 days to test everything out, and then you need to buy a license from the E3NEA, who certainly deserves the support. Some more links, for example, of the RF Pro 1B antenna. I don't think this link to the broadband dipole works anymore, but some of these other links on using the RBN are still valid. And of course, all my presentations and probably this video will be linked to my QRZ.com page if you want to go back and listen to parts of it.